This is a tutorial about our beacon design. Our beacons were to communicate with one another and also communicate to the robot. The circuitry we implemented for the beacons were easy but hard to debug. Therefore, I'm going to explain what went to design about. They consist of a voltage regulator, an IR drive circuit, and also a signal generator. Although our final design were on prepped boards, I have built the circuit on a breadboard so it's easy for you guys to see. Over here is the voltage regulator circuit implemented by a positive voltage regulator such as the LM7805C. Here is the signal generator implemented by the LM555 timer chip. This is the N-channel MOSFET P16NF06 that drives the 8 IR transmitters that the robot is to detect. This transistor is the drive circuit for the IR transmitter that will be turned on when the ball is removed from the current beacon. This is the indicator circuit that I've built to make sure we know when we're receiving a signal from the previous beacon. The circuits are powered by 5 1.5 volt D-size batteries. This provides 7.5 volts to the voltage regulator, and in turn the voltage regulator provides 5 volts. There are 8 transmitters below the beacon so that the robot can detect them and traverse towards the beacon. I want to talk about the logic of our design. When a robot is to go towards a beacon, the next beacon to robot transmitters are turned off and the current beacon to robot transmitters are turned on. This allows for the robot to traverse towards the current beacon. Once the robot has traversed towards the current beacon and removed the ball, as the ball is removed, a header pin will be removed which will cause the beacon to robot transmitters to be turned off, and also a beacon to beacon transmitter that we have implemented like so to be turned on. Therefore, the next beacon which the robot is to traverse towards, which could be either beacon 2 or the homing beacon, is receiving a signal from the previous beacon. This signal causes the current beacon to robot transmitters to be turned on, hence allowing the robot to now traverse towards the next beacon. Once the robot gets to the next beacon, the same set of events occur with that beacon and the one coming after it. In this video, I've provided the circuit design and also brief explanations that will help you in designing them or recreating them. Our voltage regulator, with its circuit design depicted in this picture, takes 7.5 volts from our battery pack and provides 5 volts for our circuitry. Through the use of the LM358 amplifier chip, the signal received from the previous beacon is amplified and used by the indicator circuit and the signal generator circuit. The following setup makes use of an LM555 timer chip to implement a signal generator. The values of the resistors and capacitors determine the frequency, peak-to-peak, duty cycle, and offset. The transistor driving the beacon-to-beacon transmitter begins with its base grounded. Once the header pin is removed, the base is no longer grounded and the transistor is biased on. Once this occurs, the transmitter is turned on. Our indicator circuit consists of a transistor that is enabled through the output of the LM358. Once the transistor is turned on, the LED is turned on, thus indicating that the current beacon is receiving a signal from the previous beacon. The N-channel MOSFET that is powering the 8 beacon-to-robot transmitters has the following setup. Its enable pin is connected to the LM555 timer chip, which is generating a square wave. I hope you found this useful.